Welcome back, y'all. We are going to extend a previous video where we built this MultiSim model of our circuit in the right-hand corner here. This is the schematic we used. In this video, we're going to actually do the circuit simulation using MultiSim's SPICE, simulation software. To do that, we need to do a few adaptations, specifically the node ordering on this one. If you go back and watch that video, I did it kind of out of order, which means node 1 here is node 1, but node 6 is node 2. So I'm just going to reorder these. To do that, I click on a node. What I want to do is move node 9 down here, but 9 is already being used. So I'm going to change this to 10 for the time being. And then I'm going to go down here and call this thing node 9. So that's the thing that I wanted. If I was smart, I would have done this while I was setting it up. Okay, the next thing I'm going to do is to get to node 8, which is the one that I wanted here. So this is node 8. Oops, sorry. Node 8 is already being used. So that's an issue. So let's go ahead and just call this number 10 as a placeholder. Oh, of course. Okay, we'll call that number 11. Okay, that's better. And then we'll call this one number 8, which is what we wanted. Okay, let's see. So 1 is here. 9 we've got. 8 we've got. 7 we've got. This one up here has to become 5, but 5 is being used already. So let's go ahead and call 5 10, since we're not using 10. And then this one would be 5. So this becomes the number 5. And then let's see, this one should be 4. 4 is being used already. This is the number 3. So 3 is not being used because I haven't used that one yet. And then over here, this should be 2. 2 is already being used. 6 is already being used. Let's see. So I want this to be the number 4. The number 4 is being used. So I'll call that now number 10. Kind of a pain to do this, right? So the best way to do this is to make everything happen while you're actually working on it. So this would be number 4. And then this one over here should be number 2. And this one over here should be number 6. So let me just go ahead and write this as number 6. And then this one is going to be number 2. Okay, let's go ahead and check that the identifications align. Okay, node 1, 6, 2, 3, 4, 5, 7, 8, and 9 is at the bottom. Very good, very good. Next thing we're going to do is actually define ground. So this relates to an example that we were doing in LANA. This is actually the one that I wrote in a paper on this subject. In that paper, I actually grounded node 9. So I'm going to go ahead and just connect ground to node 9. And that tells me this. And then what I'm going to do is measure the voltage at various parts. So this one I'm going to actually call U1, since that's what I wanted. And then over here, I'm going to do that again. Measure the voltage at node 2. And I'm going to call this U2. And to figure out where I'm getting these names from, just look at the schematic. U2 is up top, so I have that. Let me do that again, and we'll do it U3. So right now, in the circuit simulation software, we're doing the same thing that we did in the LANA algorithm when we defined the variables. This is literally just telling the software, hey, these are the values that I want you to calculate for me. And then what we're going to do is verify that the software produces similar output as the work that we did in LANA, which is pretty exciting. LANA is actually inside the core guts of this software, which I love. It is a demonstration of just how powerful linear algebra is, that it's used in modern day circuit simulation. Oops, I put that in the wrong place. I actually don't need it there. Once I've measured node 6, I want to go over to node 7. So voltage at node 7, and we'll call that U7. And then of course we also have a voltage at node 8, and we'll call that U8. Okay, and then I think I have all of my voltages here that I want, and then what we'll do is we'll just run it. So check that out. What this is doing is giving me the live implementation. This is a DC circuit, so there's actually no changing happening here. And so these are the DC values. We can capture these. In fact, I'm going to do that in a table. And what we can do is compare each of these values. So U1, U2, U3, U4, U5, U6, U7, U8. We can compare the values that MultiSim is giving us with the values that we calculated via LANA. I did want to show you how I got those so you can follow along at home. Thank you so much for your attention, y'all. We'll see more of this in future videos. Peace.